Guideline for graphing polynomial function. So let's say we graphed the polynomial function without a graphing calculator. How would we best estimate what the graph would look like? So first, we find the zero. Factor the polynomial to find all its real zero. These are the x-intercept of the graph. Then we will use the test point, make the table the value for polynomial, include the test point to determine whether the graph of polynomial lies above or below the x-axis on the interval determined by the zeros, including the y-intercept in the table. We then determine the end behavior of the polynomial, and then we sketch the graph. Okay, so let's try this. So first, we will factor the polynomial to find all the real zero. In this polynomial, we already given in the factor form. So let's set f of x equal to 0 to find the real zero. Then x minus 3 equals 0, which lead to x equals 3. X plus 2 equals 0, which means x equals negative 2. 3x minus 2 equal to 0, so x equal to 2/3. So these are the x-intercept. So let's put the x-intercept onto our graph first. X equals 3. That we know that is where the graph will cross. Negative 2 and 2/3. Okay. Now while we're here, let's try to find the y-intercept. The y-intercept is the value of f of x when x equal to 0. So f of 0 is equal to 0 times negative 3, 0 minus 3, 0 plus 2, 3 times 0 minus 2, so negative 3 times 2 times negative 2, and that is 12. So y-intercept 12. So here is our y-intercept. The next thing we do is to make the table of value for polynomial and including the test point, determine whether the graph of the polynomial lies above or below the x-axis on the interval determined by the zero. So making the table. So here's our x value, is f of x. Okay, so let's start at negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, and 5. Okay. And then we get the y. Okay, so the y-intercept here is 12. So when x equals 0, we get 12. When x equals negative 3, when x equals negative 2, that is 0. When x equals to 2/3, so we add that in. We get 0. And again, when x equals 3, we get 0. So we divide this table into this many pieces. These are the pieces that we already know. So let's calculate all this value of f of x. So now this is what we got from calculate the value of f of x. Now don't worry too much that the value of f of x is way bigger than what we have in our table. What we want to determine here is that from negative 4 to 0, this part, the graph here is negative. So that is below the x-axis. axis. Positive, negative, and back to being positive. Okay. So it seems like in this case, at x go toward negative infinity, the graph goes toward negative infinity, and at x go toward positive infinity, y also grow toward positive infinity. So let's see if we can sketch this graph the best that we could. Okay. So negative 4 is go way down, so we don't know. Negative 3 is also go way down. Negative 2, we get to 0. Negative 1, we get to 20. So 12, 13, 14, 15, 16, 17, 18, 19. So 20. Okay, so negative 1 grow to 20. And then at 0, it grow to 12. So our graph look kind of like narrow. So on this side, it look like it's going straight down. And then it turn around, go down to 12. Cross the graph at 12. And I try to make it as pretty as we can. Okay. And then it go down to negative, go down to 2/3, that way it is 0. Okay. When x equal 1, go down to negative 6. And we can get to here. And 2 go down to negative 16. Which means it's going down somehow, but then it have to make a turn to come back to get to 3 being 0. Okay, and then go on back up. So this graph is not super duper accurate, but it kind of estimate what kind of graph it looked like here in this case. Okay. Let's try this again. So follow the guideline to get the graph of f of x equal 2x to the third minus x squared minus 8x plus 4. So first thing is to find the x and y intercept. So f of x equal to 0 would mean 2x to the third minus x squared minus 8x plus 4 equal to 0. Let's factor by grouping. Okay, so this means x squared minus 4 equal to 0. So x equal plus or minus 2. 2x minus 1 equals 0. X equal 1/2. So these are our x-intercept. And let's find the y-intercept. The y-intercept is the constant term of the polynomial, so the y-intercept here equals 4. Next thing we do is to make a table of value. So here x, f of x. So negative 4, negative 3, negative 2, negative 1, 0, 1/2, 1, 2, 3, 4. So here we get 0, 0, and another 0. So when y equals 4, x equals 0. So let's fill in this table to see what happened. So now that we have the value for f of x, you can see that from here to here, the graph is below the x-axis, above, below, and then go back above. Okay. So the end behavior of the graph, the leading coefficient is 2x to the third. This means as x goes to a positive infinity, y grows to a positive infinity. As x goes to negative infinity, y goes to a negative infinity. And it's consistent with our table. So let's try to plot the graph as best as we could. Negative 1, 9. 1, negative 3. And 3, 25. So look like your graph doing this number of things. There we go. And here the domain is all real number. And the range is all real number as well. Again, this is not the super duper accurate graph. However, it tells you the behavior of what sort of graph it looks like.